Hi, welcome everyone. Glad you're here with me today. We are going to be talking about quadratic word problems and kind of definitely incorporating reasonable domain and range and looking at different calculator functions that we can apply to this. So make sure you do have your calculator when you're working with me today. Let's go ahead and let's start off with this problem. Now they give us the graph, so this always makes it a little bit easier, right? Luis kicks a soccer ball, and the graph below shows the height of the ball over time. Right? So on this one right here, we have our some key points right here. This is a key point, right? Not only is this an x-intercept, that is a y-intercept because it is at the origin. And it's always very important to understand your units right here, right? So here we know that x is going to be equal to seconds because it's on the x-axis, and y will be 0 in feet, right? Um, and that's because you have feet here on the y-axis. So that's one critical point. Another here is your vertex. Now with graphs, sometimes just due to the nature, we have to kind of approximate. And so when I pull it over, okay, right here we have 30. This right here is 35. So it's in between 35 and 40. So we're looking at, I would guess, probably about 38 or approximating. And then if I pull it straight down, right in between 1 and 2, I'm looking at about 1.5. So right here, you've got 1.5, comma 38. And I like to just make a note, hey, this is my seconds, and this is my feet. Then over here is another critical point in our parabola. Of course, parabola being the shape of a quadratic. We have a point right here called 3, 0, and that one is 3 seconds at 0 feet. So it talks to us about the starting height of the ball is blank feet. Well, starting would be always your y-intercept right over here, right? And so I'm going to go with this point with, it says feet. So I'm going to select 0. We started at 0 feet. Make sense? Okay. The ball reaches a maximum height of approximately blank feet after blank seconds in the air. Well, if we're talking about a max or a min, we probably are referring to our vertex, right? So again, here we have our vertex, okay? And this is a maximum in this situation, right? So feet would be 38, and it took 1.5 seconds. Right? Gonna scroll down here a little bit. So again, this was our starting point right here. This is where we started, starting point. Right here is where it touches the ground after so many seconds, right? This is our x-intercept. It's also our ending point, right? And so it says seconds, so I definitely want to choose 3 for seconds. Right? Now, the next thing you might ask is, well, how do you know that's your starting point and your ending point? Well, let's think about this logically, because although we have seen parabolas where there's like little arrows and it goes on forever and ever, is that reasonable? It might make sense in mathematics, however, but in reality, when we think about it, the soccer ball, when you kick it, does it go through the earth? Not unless you're like a Marvel superhero, okay? It does not typically go through the earth. And again, does it make sense to say that we are going negative 5 seconds when we, no, in this case, it does not make sense to say negative time, and it doesn't make sense to say negative height. So this is the starting point, and this is the ending point, and there is nothing after that. So if you recall with Dixie Royd, we have, and let me just kind of zoom out here just a little bit so we can kind of see it all. I'm going to go ahead here and just to refresh my brain, I got Dixie Royd, and I have domain and range. So when they're asking for the domain, they're asking all about x, right? So the x-axis goes from left to right, and that's where my focus is going to be. I'm going to go all the way from the leftmost point, right? I can draw a straight line, and then I'm going to go to the rightmost point. Okay, and that value right there on the x-axis is 0, right? And this value here on the x-axis is 3. So let me write it out. So when we talk about domain and it's continuous, not discrete with little dots, right? Continuous, then I'm going to have x in the middle. There are no open dots. Remember, solid line is a bunch of solid dots. So I know I'm going to have less than or equal to. Open dots are only for less than. My little number will go over here on the left. Little on the left, right? Both of them start with L. And that's going to go right here. So the little number is 0. And the big number is 3. So I'm going to put a little note, hey, big over here. Okay. And that's it. It's that easy, right? Let's go ahead and look at our range. Range is all about y. Again, there is no open dots. We're going to be focused on the y-axis. So y-axis goes down and up. Let's look at the lowest point here, and that is 0. And then my highest point right here, there's no part of that function line that's above it, is 38. So we have our little number 0 here, and our big number 38 right here. That's how you do it. Yeah. All right. So like I said, when they give you the graph, it's really nice, right? I'm going to go ahead here. We're going to do a couple examples where they don't give us the graph. So let me zoom in so all of you watching this on your phone can maybe see a little bit. All right. We're going to talk about athletic Adam, who threw a ball straight up with an upward speed of 40 feet per second. His hand was 8 feet above the ground. His hand? Oh, okay, yeah. So because he threw the ball and it was in his hand. Okay, got it. When he released the ball. So there's a function that models the path of the ball. Great. I'm gonna put it in the calculator. I put in y equals, and I've got negative 16. Now remember, we have y, and on the calculator we have x. So truthfully, what I'm gonna do is I'm gonna put this one in because the calculator likes it better. So everywhere I have a t, I replace it with x, and everywhere I have a y, and h, I replace it with y. So I'm going to go ahead and type that in. If it's up front, it's a negative, right? Then you got x, and you have squared, and you have plus 40x plus 8, okay? And we're going to graph it, and that looks terrible. So I already played around with this before, and I tried zoom out, enter. That doesn't make it look good. I tried zoom fit. That's like zoom 0. That's usually one of my favorites. That didn't make it look good. So let me kind of show you how you can make this look good. You go to your table, right? And I look at this now. Remember, with with the whole throwing a ball, it really doesn't make sense to have like the ball's not going to go through the earth, so it's not going to be negative. We can't go back into time, so it's not negative there. So we're really going to be focused on these numbers here. My biggest number is 32 here. My biggest number before it becomes negative is 2, so I want to keep that in mind. My x will probably be good if I make it go from 0 to 5. And my y, as long as I can cover that 32, we're good. So let me show you. You go to window, and it says x minimum. You know what? I'm just going to make it negative 1. Okay, my biggest x value was like 2, 3, so I'm just going to put it at 5. And then right here under y minimum, that's my like lowest point there, that's negative 1. And then under y max, my biggest value, it was like 32. Let me go ahead and put like 40. Okay. So now when we graph it, it'll look nice. Okay. So this is how you do it. All right. Now that we have that, and you'll notice the calculator, I mean, it graphed it backwards in time, right? And all that kind of stuff. So when we look at this, I think one really important thing, one good indication when we talk about speed at 40 feet per second, okay? That is typically, you know how we had like the change in Y or the change in X, right? And that's, speed. So that's feet per second. That right there tells us what Y is, right? Y is going to be feet, and seconds is X, right? So we know on the X-axis we have seconds, and on the Y-axis we have feet. So just a little hint right there. Now, let's get into this. How long was the ball in the air? So we're looking for the x-intercept, and specifically right here. I don't know if you can see where I'm pointing, but right there. Okay, that x-intercept. That's what we're looking for. Okay, and we all know, so we want to find that x-intercept, and we know that there's a couple different names for x-intercept. Okay, there's a root, there's a zero, and there's a solution, right? Today what we're going to focus on is zero, because watch this. Here's some calculator tip, okay? Calculator tip for today is, girls, you want to hit, I think it's second trace. Yeah, so second, you want to hit trace, and look what you have right there, 2 for 0, okay? They're not talking about like the number 0, they're talking about the x-intercept 0. And that's exactly what we wanted. So here's my little, I hit the button second, I hit the button for trace, and I hit the button 2, press, I don't hit that press, button for 2, and that will get me my option for 0. Okay, so let me show you again. That was, I'm here on my graph, right? Second, trace, 2. Okay. Now, what we want to do, we want to find this x-intercept. And we're telling the calculator where to look for it. So we're at the left. It says, okay, point me to the left of it. Well, I'm already at the left of it. As long as I'm to the left of this point right here, the x-intercept, then we're good. So I'm going to hit enter. Then I want to go to the right. And it needs to go below. So it went below because it dropped off the graph. Now hit enter. I don't want to guess. And ladies and gentlemen, it actually gives me my 0 right here. And it gives it to me at the value of 2.686. I like to usually look for a number that's 4 or less before stop. So here, my 0, my x-intercept is going to have a value of 2.686, right? Comma 0. That whenever it has like the EX, like X, that scientific notation, it means it's either a really big number or really small. It's pretty close to 0. So how long was the ball in there? We know that the X is all about seconds, and we know that Y is all about feet, and it was in the air for 2.686 seconds, okay? So I'm going to write that right here. The ball was in the air for 2.686 seconds, okay? Hope that helps. All right, so let's look at the maximum height, guys. Maximum height. Well, guess what? There's a calculator feature for that too. So let's go over here and just look at graph. We got a plain screen, right? Second trace. Second trace is going to be your friend, y'all. So you have to know when you look. We got minimum and maximum, right? You have to know when you look at the graph. Are we dealing with a maximum? Or are we dealing with a minimum? And they even say like, hey, we're looking for the maximum right here, right? So our calculator tip is going to be second trace. Second trace is your friend. So you're in the graph, right? You hit second trace. And I'm going to put here 3, that's for minimum, and 4 if you want maximum. That's our calculator did. A little box. Okay, so let's go ahead and hit max. 4. Now we know we're really looking at that vertex, that very tippy top, right? And my spider's all the way over here. I need to go to the left of that vertex. So I'm going to go to the left. I'm going to hit my left arrow. See my little spider's coming on up. And now I'm to the left. Now I'll be honest. It doesn't matter if you're right here, or if you're right here, or if you're right here. But I will tell you, don't be right up on that vertex. Give it a little space, please, okay? So, because you don't want to accidentally get too close where you don't tell the calculator to go far enough to the left. So give it a little space. So here, this little spider is definitely to the left of the vertex. You hit enter. Then we go to the right. Right? Go to the right, and then we're to the right of the vertex. I hit enter. It says, do you want to guess? No, thank you. And then I have maximum right there, right? So my value is, I've got x being equal to 1.25. And y'all don't round to the nearest number. That's middle school. We don't do that. You need to round to at least a hundredth or even a tenth. And then we got y is 33. So in the first position, we have seconds. And then here we have feet. They're asking for the height, right? So what unit best describes height? Feet. So we can say the maximum height of the ball is 33 feet. Okay. That's how you do that. All right, let's look at the next one. How long did it take to reach? Well, we can use that same information, right? How long? When they say how long did it take, they really want to know how many seconds, right? That's the best unit of measurement, how many seconds. Well, the answer to that is that it took 1.25 seconds, right? So my answer is going to be, it took 1.25 seconds to reach the maximum height. And we're done with that. All right. I think this is the last one on this particular question. Nope, we got a couple more. Okay, we got 2 more. After it reached the maximum height, how long did it take to drop to the earth? All right. So on this one, this is going to require some thought, okay? Because we know, I'm going to just draw this right here, right? Got this. But we had an X and Y right here. Something like this, right? And then it looked like this, right? And we got Y, which was all about feet. And then we had X, and that's all about seconds. And we had our little maximum value here, okay? And then we had where it hit the earth, yes? So now we know that at this point, we're talking 1.25 seconds, right? I'm gonna just kind of get into this. 1.25 seconds, okay? And at this point right there, if we go back up and we look at it, we had the point 2.686 seconds. Okay, that was how long it was in the air, right? That was that x-intercept, 2.86 seconds. So let me write that down. 2.8, make sure, what did I have there? 2.68, okay, my bad. 686 seconds, right? So what I really want to know, it says it reached the maximum height. How long did it take to drop to the earth? They want to know from here to there, right? What's the difference? Well, in order to take the difference, you take the second number and you subtract the first number, right? So that's going to be 2.686 minus 1.25. And I'm going to put that in the calculator. So I'm going to quit to get out of the graph. You hit second mode to quit. And I'm going to hit 2.686 minus 1.25. Enter. And we are looking at a time of 1.436, to be exact, seconds to drop to the earth. If I can stop. All right, and that's how you figure that out. Let's talk about reasonable domain and range, guys, okay? So when we do this, and it's not bad to have this little sketch right here, okay? Remember they said that it started off at 8, right? That number on the end, that's our y-intercept. I'm trying to think if there's a way I can check that. Let's see, second trace. Minimum, my this, my that. Probably is. But on this one right here, and definitely on your table, at your y-intercept x is always equal to 0, right? And so when you look at that, you know that y is equal to 8. That makes 8 your y-intercept. So let me go ahead and just add that to this point right here, okay? This is definitely 0 right here, but we got that point of this is 8. And then the other thing I want to add to that was my maximum value, right? Maximum value was 33. We need to take that into consideration. That was 33. Okay. And then, of course, this is just 0 because that's the origin. All right. So let's look at this. For the same reasons as we had discussed before, it just really doesn't make any sense to have the what was it? It was a ball, right? That go through the earth. No, that doesn't happen. And then also he can't throw in negative time. So when we look at this, let's talk about domain first, okay? Domain is all about x. And so this little tail right here doesn't make any sense. And actually, I'm just going to get rid of it. I'm just going to go ahead and say that don't make any sense to have it right there. So I'm going to get rid of it. Okay? And it doesn't make any sense to have anything below the earth. So I'm going to get rid of that. And now I got exactly what it's going to look like, right? So we're going to go from the very top. So right now, what am I doing? Domain or range? To the bottom. If you said range, good for you. Okay? This very, very bottom is 0. This very, very top is 33, right? And so I'm going to write out my range. Range is all about y. We don't have any open dots. My little number goes on the left, and my big number goes on the right. Ladies and gentlemen, we are done. Okay, let's try it again. Let's go with, I'll do brown. So we're going to go all the way from the left to the right, to the biggest. And if we're doing left and right, we are doing, that's right, domain. Domain is all about x. I got less than or equal to, no open dots. And this was at a 0. And this one is, looks like 2.686, right? So I'm going to go ahead. Little number is 0. Big number is 2.686. Ladies and gentlemen, we're done with that one. I would encourage you at this point to hit pause, see if you can do the next one, and then come check your answers with me, okay? Let's go over here. Welcome back, boys and girls, ladies and gentlemen. We got a new problem regarding a model rocket launched from the roof of a building. Of course, its flight path is modeled by this, where the height of the rocket above the ground in meters and t is time after the launch in seconds. All right, let me go ahead here. We're going to type that in. And again, we always just do y equals negative 5x squared plus 30x plus 10. I like to make that calculator happy. So I'm just going to hit clear all that stuff out, right? We got negative because it's right up front. Negative 5x squared plus 30x plus 10. Okay, so we have that. We're going to graph it. That looks crazy. So let me go ahead and hit zoom and standard just to kind of get like a clean slate. Zoom 6. I don't like that either. Let me try zoom out. Zoom 3. Now when you zoom out or zoom in, you want to hit enter after you hit 3. Yeah, see, that looks ugly too. And I can hit enter again, and yeah, it still looks ugly. Let's go to our table. Second table. Again, probably same thing where we're not going to be dealing with negative time or negative height. So I'm looking at my biggest value being like 55 on here. And let's see, my biggest X value before it gets to the negatives, we're looking at 10. So if I do like 10 and 60, I should be good. Let me go over here to window. I'm gonna put -5. And I think I said 10, right? And we're gonna go over here. I'm gonna put like -10. I'll put -5. And I think I said 60. I don't remember. I'm sorry. So we'll just go with 60. Hit graph. You know what? Good enough. There we go. So, and I can draw a little sketch right here, right? You know, we know that that number right here, that 10, that's our y-intercept. If we look at the graph, I'll bet you anything, you go to 0. You know, if x is equal to 0, that's your y-intercept, right? A couple of different ways we can look at that. So we know that this guy, he's going to start at 10 right here, right? So that's 0, 10. Okay. Now, it looks like the rocket, so that's some building, right, where it goes off of it, and it goes up, and then it goes down, right? Does it go through the earth? It appears that it actually is uh, launched, and we're going to assume that it does not go through the earth, okay? So, when we're looking at this, how long was the ball in the air? Okay, I need to know like all the way from here to there. Again, when they talked about t is in time, well, we replace t with x. We know that's the x-axis, and that's going to be time. And the unit of measurement for time is seconds. There we go. So that's time, and that is in seconds. And then y, or h is probably for height, right? And that was in which unit? All right, if you said meters, you are correct. Let's go right here. I guess I'll just put that right here. We got y, and we know that's height, and that is in meters. Okay, I guess I could make this big. Yeah. So I need to figure out this point right here to know how long the whole thing was in flight, right? So what's another name for that point? If you said x-intercept, good for you. That is the x-intercept. It is the end of your story, right? The end of story. In this particular case, right? So let's go ahead and find out what it is, because we know what's another word for x-intercept. Yes, it's also a 0. So according to our calculator steps, we hit second trace. Second trace is our friend, and we look for 0. So that's 2. And so I'm looking for this point. It says, am I to the left of it? Sure, I'm to the left of it. And it doesn't matter if I'm here. If I'm here, I'm still to the left of this point. So I'm going to hit enter. Then we want to go to the right. So I'm pretty much just going to make that spider disappear. Boop. On the other side, right? And I know it's in negative because the y thing. So here we go. Enter. Do I want to guess? No, thank you. Make sure, like whatever you're looking for, if you're looking for 0, that it says 0 right here, right? Okay, good. Now we got that crazy small number, and then we got this. So what we're looking at is 6.3. It was 2 like that, right? 6.3 sounds good. And then we got 0. Okay. So how long was the ball in the air? X is in seconds. This is in meters. So we know seconds is a better answer for that. For how long, they really want to know seconds, right? And so what I'm going to say, the ball was in the air for 6.3 seconds, boys and girls. What was the maximum height? Well, guess what? Keyword. Looking for maximum, right? What do I want to hit on my calculator? That's probably just the tip for the day, right? Calculator tip. Try second trace. See what looks good. See what will help you out. That's our calculator tip of the day, boys and girls. So like Sesame Street where they say the letter of the day is. Right? Okay, anyway. Maximum. So I'm gonna let me just graph. We'll look at it plain, right? Second trace. Now I'm gonna tell you all these second trace things. Like you actually have to see the x-intercept before I give you x-intercept, right? You have to see the maximum. If your maximum is off the screen, I don't think it's gonna work. So second trace. Oh, I don't like that. Let me try. Second. It didn't get the second. Second trace. Here we go. Maximum, right? So I want 4. I'm going to go to the left of the maximum point. So I'm going to pull my little spider, make him go to the left. Don't, give the vertex some space. There we go, enter. Then we're going to go to the right. Give it a little space, right? Okay, I want the maximum. Does it say maximum? No, so I hit enter. There, maximum, right? Y'all, we're going to round this because, 5 or more raise the score, right? So 2.99999, real close to 3, okay? So I'm going to put that right here. I've got 3 and 55. Sorry. Okay, so I know that x is all about seconds. That's 3 seconds. That's 55 meters. Boom. What is the maximum height? Which one describes height, meters or seconds? I would say meters, right? That's what they want. So let's go ahead and let's write our answer. The maximum height of the ball was 55. Let me erase that. I don't want people to think negative. 55 meters in the air. We're done. How long? What best answers that question? Seconds, y'all. And since we're talking about maximum, we're still talking about the same point, right? How long did it take to get there? Well, they want to know seconds. And so when we talk about it, we say it took 3 seconds. That's not very long. That wasn't a ball. Wasn't this a rocket? Oh my goodness, look at that. Rocket. Rocket. Okay, that's just that part of me. How long did it? It took, so that was not ball. Sorry, I gotta change this. I can't help it. Rocket. Okay. It took 3 seconds for the rocket to reach its maximum height. Okay? After it reached the maximum height, how long did it take to drop to the earth? Okay? So again, what they're looking for, I should just go off of this one here. So once it got here, they want to know how long did it take to go from here to there, right? All right. So on this one, we already said, so how long? That means seconds, right? So we're going to be focused on seconds. Let me kind of write that down. How long? That means seconds. So we want to focus on the seconds, and we just want to know the time from 3 seconds to the time it takes to get to 6.3 seconds. So the difference between those two, okay? Well, the difference between I should just zoom out. We have 6.3 minus 3, right? Let me double check. Yeah, 6.3 minus the 3. Ladies and gentlemen, you can put it in your calculator, but you should end up with 3.3 seconds, right? To reach the maximum height. Okay? Next, what is a reasonable domain and range for this situation? So, ladies and gentlemen, we talked about how it doesn't make any sense to have like the rocket's not going to be shot like negative 10 seconds, right? We're not going to have it go through the earth or anything like that. So we're basically looking at our domain and our range here. So let's go ahead right here. Smallest number is 0. Biggest number is 6.3, right? This is all about x. X is all about domain. So I'm going to go ahead and write that down. Domain is all about x, less than or equal to, less than or equal to, no open dots, 0 to 6.3. Okay? Our range, all about y, no open dots, no open dots. And we want to go from bottom to top, just like the y-axis does, right? So I'm going to go right here, and I'm going to put, I feel like a pastel. So let's go here all the way from the bottom. Okay, at this point, we're looking at 0, and we go all the way to the top, and my biggest y value is 55, right? That's all the way from 0 to 55 right here. Okay, when you do this, make sure you don't have any part of this function line going, whoop, anything like that, right? You want to make sure you're at the very tippy top, right? So we're going from 0 to 55. Little number goes on the left. Let me make a bigger, darker number now, right? 0 to 55, y'all. All right. Well, I hope you picked up some tips, help you along the way. Y'all have a beautiful day, and thank you for spending this time with me. Take care, y'all. Bye-bye.